Section 9.4, Properties of Logarithms. One property of logarithms is called the product property, which states that the log of some base b of m times n, there's your product, equals the log base b of m plus the log base b of n. So we can separate our product into two logs. For example, if we have log base 8 of 8x, that will equal the log of base 8 of 8 plus the log of base 8 of x. Now, another property of logarithms states that if your base is the same as the answer, the entire logarithm equals 1. So now we have 1 plus the log base 8 of x. We can also go the other way. Let's write some as a single logarithm. For example, if we have log base 5 16 plus log base 5 4, as long as our bases are exactly the same, we can write this as a single logarithm using the multiplication property or the product property, which states that we would have log base 5 of 16 times 4, which gives us log base 5 of 64. Quotient property of logarithms states that log base b of m divided by n equals log base b of m minus log base b of n. For example, if we have log base 7 of 9/5, that will equal log base 7 of 9, the numerator, minus log base 7 of 5, the denominator. Always numerator first, denominator second. The power property of logarithms states that log base b of m raised to some power r equals r times the log base b of m. Notice we put the exponent r out in front of our logarithm and multiply. For example, if we have log base 8 of n to the second power, that equals 2 times log base 8 of n. Special properties of logarithms. Log base b of b to the power of x equals x. So the answer is the exponent when the base and the answer here are both the same value. The next special property is b to the power of log base b x. When this base on the exponent is the same as the base here, the answer again is x. The next special property, log base b of 1 equals 0. Whenever you have a 1 right here, the answer is 0 because the base to a power of 0 equals 1. For example, log base 2 of 2 to the 5th power. The base is the same as the number here. It equals our exponent 5. Another example for the second special property. If we have 10, log base 10 of 9, since our base on our log is the same as our base here, the answer is 9. And finally, an example for our third special property. Log base b of 2 equals 0. B must equal, I'm sorry, I put that in the wrong spot. That should be log base 2 is 1. Therefore, 2 to the 0 power equals 1. So the answer must be 0. Use multiple properties to simplify your logarithms. First of all, we are going to use the exponent property. Notice we have a number out in front of each of our logs. Those are our exponents. So we're going to write that as log base 4 of 2 to the 3rd power plus log base 4 of 5 to the power of 2. Now we are going to evaluate those exponents. So we have log base 4, 2 to the 3rd power is 8, plus log base 4, 5 to the 2nd power is 25. Now we are going to rewrite this using the product property, which states that we can write it as a single logarithm, log base 4 of 8 times 25. Now we can calculate out 8 times 25, and we get a final answer of log base 4 of 200.